This video is on vectors in Maple. It is about how to create vectors with Maple, how to do simple arithmetic such as addition, subtractions, and scaling, and to visualize them in Cartesian coordinates. Let's get started. Okay, so what is a vector? Well, a vector is basically a column of numbers. It has usually more than one dimension. So if I say v colon equals, and then I create the vector by using the greater than sign, 1, 2, 3, this is a vector of 3 components. The first component is 1, second component is 2, and the third component is v. A lot of times people like to put a vector sign over the v. So we'd like to put an arrow over it. So what we do is we can say v. And then what we can do is we can either in a Mac hold the command button down while holding the shift button down and then pushing the double quote button. So this puts the cursor over the V, then we put a dash and greater sign, and that creates the arrow, and then we go to the right and we're out of the vector, and then we can say 1, 2, 3. You should note that V without the vector sign is not the same as V with the vector sign. These are two different entities. I'll be making mostly vectors with vector signs, so you can play along. Here's another one, V2, make the vector sign over it, command shift and then double quote is equal to, and again you can put anything in here, ABC, and that will be a vector with the 3 components A, B, and C. Sometimes it's useful to make a vector which has all the components the same value. So let me make a vector that is filled with 9s. So we'll call this the V with the vector sign over it, then get out of it, and I put an underscore underscore 9. And this is going to be a vector, so we use the vector procedure. We'll make there are 4 9s in here, and we'll put the 9 in like that, and you can see it is filled up with 4 9s. Another useful vector that we make frequently is the one with a random numbers in it, so I'll make V underscore underscore random. And the way one can do this quickly, unless you need to make a huge vector, in which case you should look at the help. Vector, we'll make it out of 3 components, and it's a random number that scores from, say, minus 5.0 dot dot to 5.0. And it fills it with 3 numbers that are floating point numbers between those 2 elements. Also, what you can do is you can use the components to make some calculations. Here's a simple way to calculate the length of a vector. Most time you might want to use the word norm, but it shows the same idea. Let's say we want the length of the vector v2. Well, what does that mean? That means taking the square root of v2, the vector, the first component, and squaring it, adding it to v2, the second component, and squaring it, and adding it to v2, the third component, and squaring it. And the result is, not surprising, v2 is a squared b squared plus c squared. Okay, let's say you do have vectors now and you want to do addition, subtraction, some scaling like that. Here are 2 simple vectors of just 2 dimensions. It's exactly what you expect. So if I make a vector v, which is the combination of 1 and 2, I just simply take v, the first one, and add it to v, the second one, and not surprising, you get an answer that looks like that. So it should read exactly the way that you would normally do it in mathematics. I can also scale a vector. For example, let's say I want to make the v0 vector, which is a creation of v0, the scalar, times the vector of cosine of theta and sine of theta, and 0, and it will multiply all the components inside the vector by the scalar v0. And again, remember, v0 without the vector sign is not the same as v0 with the vector sign. All right. Then, of course, once we create a vector, it'd be nice to be able to visualize it. So here are some simple examples to how to see what a vector looks like. I'll restart and create this vector v1. There is a procedure in the plots package that allows you to create arrows. So we'll create the arrow A1, which is made with plots, :dash to say it's within the plots package, and it's called arrow, and that's a pretty simple name, and so it will be, and we just give it the vector that we want to put in there, and it will make the plot looks like that. Most of the time it's actually easier to load in the plots package, so I'll use the word with plots, and I'll put a colon so it doesn't show all the procedures within the plots package. Let's make another vector, v2, which is out of -2 and 1. And then we'll make a2, that's not 2, arrow. This one will use the vector v2, and then we can put all sorts of fun things in, like its color is equal to dark blue, and its shape is an arrow. I'm not going to display it, but rather I will then display it this way by putting in A1 and A2 and making the scaling equals constrained. And we'll make a size of 200. And so it looks something like that. So you can see that you're going to get two different shapes depending upon what you describe as the shape of the arrow. All right, why don't we create an arrow that starts at the location 1 and goes to the location 2. So we want to start over here and go to here. That means we are looking for the location v sub 2 relative to v sub 1. So I'll call that v dash greater than, not 2, 1, which is I want to go to v2 relative, minus sign, the location of v1. And that's the value there. Then what we're going to do is we're going to place that. Normally it defines the arrows from the origin, but we're actually going to place it in making our arrow number 3. We're going to start it at v1 and then plot the arrow 2, 1. Let's put some color in here. Color equals orange, and width equals 0.2. So again, there are lots of ways you can make changes to this, and now we can display everything together. I'll actually just copy and paste this. Copy, paste, add in my A3, put a comma, and we'll make the size 300 by 300, and when we hit go, it looks like that. Finally, we can always make something in 3 dimensions. I've created three-dimensional vectors. I've also created one of them as the sum of the 2. I've created 3 different arrows, and I can display them now, and they look like this. Okay, I haven't labeled them. I should have labeled them there. And then what you can do, of course, is you can then rotate them from here to here. Actually, this is pretty easy to tell. This one, V12, is the combination of V1 plus V2. So I notice I actually put V2 up here, and then you can display it. There are more examples in the document. I encourage you to look at them, and I encourage you to do the practice problems. If you have any questions, leave a question down below.